Hi there, it's me again, Mr. O. Today we're gonna go over with compound inequalities. From this point, we have learned simple inequalities. You know, the x greater than 5, x less than or equal to 7, and we know how to graph those. And those simple inequalities, when they're being combined in the similar or in the same statement, then now the problem have two simple one, then it becomes compound inequalities. Okay, so what happened when we combine them? What if they're together? This is where the problem are divided into two concepts in math: the union and the intersection, or the and and the or. Okay, just remember this: when you're having an and, you're looking for the commonality, the intersection of the two inequality. When you have or, you combine them, you put them together, and that's the entire answer. So sometimes when you have an and problem and you find for their intersection, but they don't have any common, then the answer may lead to a no solution. And when you have an or problem and you're looking for everything, and it so happened that they have so many in common and everything is common to them, that means the answer will be all real numbers. This may not make sense right now, but I just want to give you an understanding that if it's an and, you look for the intersection. And you need to write it in your bell work or in your notes that if it's an and problem, you look for the intersection. If it's an or problem, you have to combine them all together. Okay? So again, compound inequality is when two simple inequality are combined or compound in the same statement. So here we have all real numbers greater than 2 and less than 6. The word and signifies that is the intersection of the numbers that are greater than 2 but less than 6. And we write it with x greater than 2 and x less than 6. Or we can rewrite it wherein it's a compound expression wherein it's written like 2 less than x less than 6, but we don't read that way. We read it from the middle, saying that x is greater than 2 and less than 6. Okay? When you graph it, you will see that they're shaded in between the range of 2 to 6. Also, I need to emphasize this to you that 2 is all the number on the left, or here, 2 is the smaller number incomparable to the right number. And for this one, it's the same thing as that one, except there's an equal sign. And if there's an equal sign, you will see that the graph here is close, which we have learned from the previous video, that if there's an equal sign under the inequality or is part of the statement, we close that number. That means it's included as part of our solution. For the word or, which is a lot simpler, if you notice, there's no other way of writing them down compared to the word and. It's just a straight x less than 2 or x greater than 6, as simple as that. And if you notice, both it's kind of split here. So if it's or split, it's a good guide, and it's connect. So, and there's an equal sign, you just put a bubble it and make it close. So what did we learn from there? If it's an and, it's the intersection, or and, it's going to connect it. If it's or, it's going to split, and, or. And, or, intersect, split. That's how you know for and or. Now, solve each compound inequality and graph its solution. So, what kind of problem is the one on the board? It's an or problem because you see the word or. Very simple. Here, we're going to work them out separately. First problem on the left is negative 3r minus 5 greater than or equal to 25. So for the r, by adding 5 here, this will give you negative 3r greater than 30, and divide by negative 3, r is less than or equal to negative 10. Remember, when you divide or multiply by a negative number, the inequality, the symbol flips. Then the other one is negative 10 plus 10r greater than 0. We add 10 here. That gives you 10r greater than or equal to 10. Divide by 10, r is greater than or equal to 1. Don't forget to drop the word or. So your answer for this problem should be this, for the solving part, including the word or. But how do we graph it? Where is this going? From the negative 10, it's shaded. Where is this pointing? To the left. Where is this going? The 1 is right here. It's close. Where is this pointing? To the right. And that's the answer. Split. Number 2. Again, how do we read this one? We don't read it as 3 less than 9 plus 6r. That's wrong. We read it as 9 plus 6r is greater than 3 and less than 69. So how do we solve this one? Watch here. The goal here is to make the variable by itself in the middle. Okay? So how do we make the variable r by itself there? We subtract 9, we subtract 9, we subtract 9 to all sides of the inequality here. We cross it out because that will give you 0. 3 minus 9 will give you negative 6. Drop the less than, drop the 6r, drop the 60 there. ¿Entiendes? Now here, our goal is to leave the r by itself by dividing it by 6, 6, 6. Crosses out. What's negative 6 divided by 6? It's going to be negative 1. Less than the r, the 6 are gone. So it's going to be r there left because 6 divided by 6 is 1 again. 60 divided by 6 is 10. Now, this is our solution. The meaning of that one is that every number from negative 1 to positive 10. Or it's better to say every number that are bigger than negative 1 and less than 10. So how do we graph it? Okay, think of this one this way. Let's focus on the yellow one. What are the numbers bigger than negative 1? This is a negative 1 here. It's open because it's open right here. What are the numbers bigger than negative 1? The numbers that are bigger than negative 1 are 0, the positive numbers, the 1, 2, 3, 4, 5. Right? So where is that one? Is it on the left or the right side? We know it's going to be on the right side. Another way to write it down, instead of writing the yellow one, we can rewrite it r greater than negative 1. And where is this pointing, guys? It's pointing to the right. That's why our graph here is going to the right. Now, let's focus on the blue one. The blue one says r is less than 10. Where is 10? The 10 is right here, and it's open. Where is this pointing? It's pointing to the left. You can see the blue and the green graph here. What did I tell you first a while ago? When you have an end problem, are they going to combine or intersect? You're going to find the commonality, the intersection of the green and the blue graph here. And you can say that the graph is from negative 1 to 10 is the common, this portion here. So the final answer is that, can I leave it like that? Yes. You make sure that you emphasize the range of negative 1 to 10, given that negative 1 and 10 are open. They're not part of the solution. Next, this time, it's an end problem, like this. By the way, the previous problem, it did not say the word or, so it's assumed it's going to be an end problem. Here, the statement is given that it's an end problem. So we will work them separately. So 10 minus 3b less than 37 and 6 minus 5b greater than 11. So let's just work it out the regular way of solving inequality by subtracting 10, negative 3b, 27, divided by a negative number, negative, take note. So this will flip over and negative 9. And minus 6, drop the negative 5b, don't forget that, greater than 5, divide by negative number again, so b there is less than negative 1. If you notice, we flip it over because we divide by negative 5, and this is our solution. Let's graph it. The negative 9 is right here, it's close. Where is this pointing? To the right. This negative 1 is right here. It's open. Where is this pointing? To the left. So the final answer, if you will ask me, is this portion here, including the shaded portion and the circle right here. Okay? I hope you learn now how to solve and graph compound inequality. And just remember, if it's an end, you find the intersection, the common to them. Later on, we will learn the special case. What if there's no common about them? Then there may be no solution. And for the OR problem, we combine them together. Okay. So what if they're going the same different direction? If it's an OR, it may cause us all real numbers. I will explain that one in the next topic. Okay. All right. I hope you learned something. Kaboom. Boom.